Hey everyone, so welcome to lesson 3, day 2 of our unit 4. I cut us off a little short yesterday because I wanted to spend a day on just word problems and catching up on whatever you need to catch up on. So um, looking at just the applications of these, the way to solve them will be exactly the same. We're going to use substitution or elimination, but we're going to focus on the setup of the problem itself. So identifying your variables, getting those equations written, and then using those methods to solve. So a circular piece of sheet metal has a diameter of 20 inches. So remember, the diameter is all the way across the circle, no matter where you draw it, as long as it goes through the center. The edges are going to cut off to form the rectangle that has an area of 160 inches squared. So that's the area of the inside of this rectangle. What are the dimensions of the rectangle? So remember, area of a rectangle is length times width. We don't know either the length or the width of this rectangle. And we do know that the diameter is 20, and you can draw a diameter anywhere. I could draw the diameter here. I could draw the diameter here. Okay, but I can also, in terms of this rectangle, erase those, draw the diameter from here to here. So that goes across the circle through the center, but it also has relevance to this rectangle in that it's the diagonal of the rectangle, if you remember some of your geometry terms. And because this is a rectangle, it has a 90-degree angle, and the diagonal of this then figure here, this right triangle, can be found using a squared plus b squared equals c squared, where you have a, b, and c. Okay, well, a for this rectangle is the length or the width. This is width. D is the length, and C is 20. C is your diameter. Okay, so we can plug those in. The length squared plus the width squared is equal to 20 squared. So length squared plus width squared is equal to 400. Right, so there's one equation, right, using our right triangle and Pythagorean theorem. We also know that the area is equal to length times width, and we know that the area is 160. So we can say, okay, well, LW equals 160. Right, so this is an elimination or a substitution problem. Because of the multiplication of these two variables, I would use substitution. It gets a little messy if we're going to try to use elimination because we're not going to have any like terms. So remember, to use elimination, look to see, do you have the same variables with the same exponents involved? And we could get there here, but the L and W are still attached, so they won't, we'd still have to substitute in some way. So I'm going to divide, and it doesn't matter what you divide by. I'm going to divide by L. So that W is 160 over L. And then I'm going to substitute that in. So I have L squared plus, oops, I said I was going to, and then I didn't, plus W squared. So plus 160 over L squared is equal to 400. And so when you square a fraction, square both the numerator and the denominator. And so I'm going to take 160 squared, which is a big number, and that's okay, over L squared is equal to 400. All right, to solve from here, I need to clear my fractions, and so I'm going to multiply everything by L squared. So I get L to the 4th plus 25600 is equal to 400 L squared, noting that here they would cancel. This is like a quadratic in that I will be able to factor it. So I want to get it set equal to 0. Move this over. And then factor, so L squared, L squared. I'm going to have both of them be subtraction because they add to negative and multiply to positive. Okay, so I factored out to the side. You didn't need to watch me do all that. So 80 and 320 are our factors for this. So minus 80 minus 320 will multiply to 25,600 and add to negative 400, which means that L squared is equal to 80 and L squared is equal to 320. Typically what happens is one of these is going to be your width and one is going to be your length. So we've actually gotten both answers here. We're going to take the square root. Because it's a word problem, we don't need the plus or minus because we can't have minus a dimension. So we have 8 and 10 if we break this down. So that one is 4 root 5, where this one is, okay, and then the other one reduces down to 8 root 5. Zoe, sorry, you guys have to hear my dog. All right, so those are going to be your answers. You can double check them if you want up here. So to check, just plug it into your original equations up here and just type it in your calculator just like this. If you take the square roots and end up rounding, it's not going to turn out exactly. So just be aware of that. That's why we leave things in radical form when we're checking. Okay, so this again is your length and your width, so it doesn't, it's a rectangle, it doesn't really matter which one you call which. But when you solve those out, you get both answers. Okay. The other kind has to do with quadratics. So a hill is inclined, so it has a slope is 1/2, as shown in the figure below. So the rise over your run is 1/2. We introduce the coordinate system with the origin at the base of the hill and with scales on the axes measured in meters. So meters high, meters far. A rocket is fired from the base of the hill in such a way that its trajectory, its path, is a parabola. And this is the equation. So the equation for this parabola is negative x squared plus 401x plus 0 because it started here. At what point does the rocket strike the hillside? How far is this point from the base of the hill? So if this is the line, y equals 1/2 x, we want to know where does it hit this line here. So what is this point of intersection and how far out is it horizontally? Okay. So we have, again, our two equations. We have y equals 1/2 x, and we have y equals negative x squared plus 401x. I would use substitution for this, but since I used substitution already, we can talk about elimination. If we, let's multiply this one by 80. and then reline this up. So 80y is equal to 40x, and the other one won't change, so I'm going to put it underneath. And then subtract. So we hit 79y is equal to x squared. And that's messy. So see, elimination doesn't work very well on this one because I still have a y in x squared. All right, so let's try this again the other way. Let's take our y value and substitute it in. So we get 1/2 x is equal to negative x squared plus 40x. So 0 equals negative x squared plus, I would write that as 79 over 2x, which is 39.5. So that you can then multiply everything. I'm going to multiply by -2 and get rid of the negative and the half at the same time. So we get 0 equals 2x squared minus 79x. So x, take the x out, we get 2 x minus 79. So x equals 79 over 2, and x equals 0. Well, we know when x equals 0, y is also equal 0. When x equals 79 over 2, which is this horizontal distance that we were looking for, we want to know what is the y value here of the point of intersection. So we plug that in up here. So we get 1/2 times 79 over 2 is 79 over 4, which is 19.75. And so the point strikes the hillside at an elevation of 19.75. I believe this was in meters. It says somewhere in here. Meters. It's the point from the base is 79 over 2, which is 39.5 meters. It says nearest centimeter. Just don't cut that off. Don't round back up to 40. Right? And that's it. So solving those systems, finding those points of intersection, which represent elevation and horizontal distance. All right, so try out the couple that I'm posting for that. Try the challenge problems as well as you go through. And then don't forget to take your quiz today and grade your lesson assignments. All right, have a good day.